right, so in this video, we're going to be talking about the domain of compositions. We need to really make sure that we understand how compositions work. So we need to make sure that we understand that you have an inner function, in this case, g of x, and you have a set of inputs, which are x, that go into g of x. So you need to make sure that you have the right domain for g of x. And then the output of g of x is going to be the appropriate domain that goes into the outer function, in this case, f of x, all right? So the domain of the composition must be the set of inputs that in the domain of g of x are also in the domain of f of x, all right? So the domain has to fit into both functions. So let's take a look at what that's going to look like. So one of the things I want to bring to your attention, and a lot of students struggle with at the beginning is when they're used to domain, is knowing when things have restrictions. So the most common functions with restrictions are going to be rational functions, which indicate that you have a fraction, and specifically that you have a variable in the denominator. All right. So let's just remind ourselves that it is okay when 0 is on the top, but no if you are dividing by 0, all right? So when you divide by 0, you get something that's undefined. So you have to make sure that you find the restriction, so that way you can exclude it from your domain. And then we're going to be talking about radicals with even roots. Remember that we do not want to have imaginary numbers. So in order to prevent imaginary numbers, we are going to set that radicand to be greater than or equal to 0, because we want the set of positive numbers. Okay, so just a reminder that you're going to set the radicand to greater than or equal to 0 to ensure positive numbers. Okay. Now, you also have to pay double attention to, sometimes it's okay to be 0, sometimes it's not. It depends on if it is also in the denominator or not. And then we have logarithmic, which we haven't gotten to yet, so we will discuss that when we get there. All right, so let's take a look at A. It says find the domain of a rational composition. So let's take a look at the domain of F. So let's make sure that we know how to find the restrictions, and then we will look at the domain of g of x, right? So if we look at the domain of f of x, right, what is the value of x that it is not allowed to be, because we do not want to end up with a zero in the denominator. So remember, that technique is just to set your denominator to not equal to 0 and then solve for x. So we know that x cannot equal 1. And that's going to be a key idea in just a minute. Now let's take a look at the domain of g of x. All right, we're going to do the same thing. We're going to set the denominator not equal to 0 and then solve. And we're going to get x is equal to 2/3. Or rather, x cannot equal 2/3. So because g of x is our inner function of this composition, for sure we know that x cannot be 2/3. So according to the domain of g, it could be anything except 2/3. The problem is, and this is what happens, we know that the input, so whatever comes out of g of x, is the input of f. We know that we cannot input 1, because if we get 1 as our input into f, we end up with something that is undefined. So we know that the output of g of x, we know that the output of g of x cannot equal 1. Okay, so that's the idea of trying to find the appropriate domain, that going back into the f function. So let's go ahead and set that up algebraically. So 4 over 3x minus 2. Remember that this is your g of x. I need to find the value of x in my g function that is going to give me the 1 so that I can exclude it from my domain. So I am going to multiply both sides by 3x minus 2. And now I've got 4 cannot equal 3x minus 2. I'm going to add 2. I've got 6 cannot equal 3x, divide by 3, divide by 3, x cannot equal 2. Okay, so what that is saying, let's say that 2 is over here, we cannot equal 2. And the reason for that is if I were to plug in 2, okay, if I were to go f of g of 2, well, g of 2 is going to end up giving me a 1. And we already said that the input cannot equal 1 because it's going to be a divide by 0 error. So if we go back and take a look at this number line, this graphical chart, let's go ahead and put that into interval notation. So we would have negative infinity to 2/3, not including 2/3, union 2/3 to 2, not including 2, and then 2 to infinity. And so this would be the domain of that composition. All right, so let's take a look at finding the domain of f of x here, and then a domain of involving a radical, or specifically an even root. So let's make sure we understand that f of x, the domain of f of x, is all real numbers. This is just a linear equation, and so we have no restrictions. But g of x, if you remember, we have to set that radicand 3 minus x needs to be greater. It's okay to be 0 in this case because it's not in a denominator, and it needs to be positive. So we set it greater than or equal to 0 to ensure this is the part that gives us positive numbers, right? Anything greater than or equal to 0 are positives. So we're going to subtract 3. If negative x is greater than or equal to negative 3, divide by negative 1, we get x, and we've got to flip that inequality. X is less than or equal to 3. So the domain of this is going to be x is less than or equal to 3. So if I just drew my number line, then I've got this thing going on. All right, so I'm going to clean up my workspace over here a little bit. All right, so now that we've identified each domain, let's just take a look. Remember that your inner function definitely needs to be represented. And g of x, my domain, is right here, and that's represented. And then you ask yourself, is there any restriction as my input of f? So what are my restrictions of f that I need to be concerned about? Well, if the domain of f is all real numbers, then there is no additional restriction. And then therefore, this is the number line that needs to be put into interval notation. And so the domain of this composition is negative infinity to 3 with a bracket. So you guys go ahead and try finding the domain. I'm giving you a rational and a square root, and see how well you do. Okay, so I've got f of x and I've got g of x. The first thing you want to do is find the domain or the restrictions on f of x. We should recognize x cannot equal 2. On g of x, we can recognize that x would have to be greater than or equal to negative 4, okay, because your radical by first is not in the denominator. So we are asked to do this inner function g of x. So I'm just going to go ahead and do the number line with negative 4. It's allowed to be. Now the problem is, again, now that f has a restriction, right? So g of x, we have our domain of g of x, but we need to make sure that the output of g is not 2, because this 2 would be the input for f. So what we need to do is to take our g function. Let me write out what we're doing. Our g of x cannot equal 2. all right? Because if it did, the 2 would be the input into f, and we're not allowed to have that, right? So we've got rad x plus 4 is equal to 2. And now we're just going to solve algebraically, right? We're going to square this. We've got x plus 4 is equal to 4. Therefore, x, I should say, cannot equal 0. So 0 would be an open circle. And that is because if we were to plug in 0 into G, right, because this is what it's saying. If I were to plug in 0 into G, yeah, I would get 2, right? This would give me 2, and then evaluate f of 2 is going to be undefined. And that's why we have to exclude it. So we're going to take this picture and put it into interval notation. So -4 to 0, union 0 to infinity. And then that would be your domain.